Welcome to Module 7D, Physical Science. We're going to be learning about air masses, and this is the last video for this module. Here's the last of the vocabulary. Go ahead and record it, and record the definitions as you're watching the video. Let's begin with air masses. Air masses are large bodies of air with relatively uniform pressure, temperature, and humidity. Looking at figure 711, you can see that we have Arctic air masses, maritime polar air masses, continental polar, maritime tropical, continental tropical, and maritime tropical. Let's break those down. When an air mass moves to a region, it brings the weather characteristics of the region where it was formed. Meteorologists, who are scientists who study weather, can predict the kind of weather a region will have by predicting what air mass will be moving over the region. There are three types of air masses. We have Arctic, which is very cold; polar, which is cold but not as cold as Arctic; tropical, which is warm; and there are also additional subcategories for polar and tropical air masses. So you can have maritime air masses, or maritime polar or maritime tropical, which are formed over the ocean, and continental polar and continental tropical, which are formed over a continent. They will be different. Remember that there are differences in temperature between air over water and air over land. Maritime tropical, and here's a notation for it, a small m and a large t, are warm air masses formed over the ocean. They generally have high humidity. They're warm and moist. We have maritime polar, and those are cold and moist air masses formed over continents. They have lower humidity and they're cold and dry. These air masses cause weather fronts. A weather front is a boundary between two air masses. Weather fronts are created when air masses move and encounter other air masses. The masses collide and fight to take over the region. There are four basic types of weather fronts. We have cold fronts, warm fronts, stationary fronts, and occluded fronts. Let's look at cold fronts. In a cold front, the cold air mass moves in a region of warmer air. So you can see this cold air mass moving into a region that already has warmer air. Cold air sinks and wedges under the warmer mass and lifts it up off of the ground. The warm air then condensates and becomes clouds. If the warm air is moist, severe weather clouds can form, usually beginning with cumulus clouds and going up to forming cumulonimbus. Cold fronts generally cause the most severe weather systems. So that's when cold air moves in and pushes warm air masses up. Warm fronts are warm air masses that move in a region of colder air. The warm air rises and moves over the cold front. The cold air below flattens out, and it forms this upwardly sloping front that can stretch for hundreds of miles. This kind of front is usually less violent than the previous front that we discussed, the cold front. Cirrus clouds are formed. The rain that forms from this type of front will be lighter, but will last longer than a storm from a cold front. So if we look back here, you'll have more severe weather with a cold front, but it won't last as long. With a warm front, you'll have less severe weather, but it'll last longer. The third type of front we have is a stationary front. A stationary front forms when two air masses collide and neither moves. A stationary front looks like a warm front, but the winds blow in opposite directions, up and down the front instead of against the front. So they're going back and forth, back and forth. Consequently, the weather tends to stick around longer than a warm front. So you'll have stratus and cumulostratus clouds together, which will eventually dissipate to cirrus clouds. And at some point, one of these masses will move, and then the other mass will dominate. The last front is the occluded front. This front occurs when two fronts that are moving in the same direction collide. This can happen because cold air masses travel faster than warm air masses. So we've got cold air moving in quickly, and we had a warm air mass there, but the cold air actually is able to push past it and compress the cold air mass. So it overtakes the warm air mass. The front starts out as a warm front, but ends up more like a cold front. As the weather begins to slow, it will have, or as the weather begins to dissipate, we'll have a slow light rain, and then it will develop into a severe weather front. So this is what happens when you'll just see scattered showers, and then suddenly you'll have these downpours of weather. So this is it for our videos for Module 7. If you need any assistance, please contact me. God bless.